Hey everyone, welcome back to another pre-algebra lesson. In this video, I'm going to be talking about fraction basics for pre-algebra. This lesson is going to be taught from the standpoint that you already have some background knowledge on prime factorization, GCF, LCM, and what it means to be relatively prime. While some of this lesson is going to be dedicated towards fraction basics like converting forms, the main objective of this lesson is to help you apply your understanding of the GCF, LCM, and prime factorizations to fraction concepts. It's my hope that by the end of this lesson, you have an understanding and appreciation for how the GCF and prime factorizations are related to simplifying fractions. In addition, I hope that you'll see that you can use the LCM, or LCD in this case, to add and subtract fractions effectively. For those of you that stick around to the end of the video, you'll see that I'll then apply all these concepts to variable expressions as well. Let's get into it. Let's begin with a little vocabulary to help you understand the lesson a little bit more clearly. Let's start by considering a fraction like 3/4. Simply put, 3/4 represents 3 out of 4 parts of something. In this fraction, 3 is called the numerator, while 4 is called the denominator. The line between the numerator and denominator is what we call the fraction bar. Please keep in mind while you're on your math journey that fraction bars also serve as division symbols as well as representing ratios and rates as well. Now that we've covered these first 3 vocabulary words, let's move on to the fourth one. When you see a number like 5, 5 is what we call a whole number. Whole numbers are easily spotted because they have no fractional parts. If you ever need to write a whole number as a fraction, you just write it over 1. 5 is the same thing as 5 wholes, or 5 over 1. That brings us to mixed numbers. 7 1/2 is an example of a mixed number. The reason why we call 7 1/2 a mixed number is because it's not just a whole number and it's not just a fraction. Since it's a combination of the two, we call it a mixed number. Now let's talk about proper and improper fractions. Whenever you see fractions like 1/2 or 3/4 or 5/8 or something like 9/10, these are all going to be called proper fractions. When looking at proper fractions, it's important to note that the numerator is always smaller than the denominator. Unlike proper fractions, improper fractions have numerators that are greater than the denominator, for example 7/3, 5/2, or 6/5. Keep in mind, however, that if the numerator matches the denominator, it's still considered to be improper. These fractions right here are just a few examples of improper fractions. That just about wraps up the fraction basics. Remember that the GCF represents the greatest common factor. If you consider two numbers like 12 and 18, the greatest common factor between them would be 6. While 1, 2, 3, and 6 are all common factors of 12 and 18, 6 is the greatest common factor. Since 12 and 18 have a greatest common factor that is greater than 1, we say that they are not relatively prime. Remember, when 2 or more numbers are relatively prime, it means that their greatest common factor is 1. While the concepts of GCF and relatively prime are revolved around factors, LCM and LCD are revolved around multiples. Let's quickly review an LCM example. When we consider the numbers 15 and 9, their LCM would be 45. While multiplying 15 and 9 will get you a common multiple of 135, if you divide that by 3, which is their GCF, you actually get their least common multiple, which is 45. In this lesson, we're mainly going to be talking about the LCM as an LCD. While LCM stands for least common multiple, LCD stands for least common denominator. Imagine if you had the fraction 1/15 and you were adding it on to 1/9. When adding and subtracting fractions, we need to have common denominators. While 15 and 9 can use an infinite amount of different common multiples, 45 is their least common multiple. Here we can see that 15 times 3 and 9 times 5 will get us 45. Whatever we do to the bottom, we also have to do to the top. Here we can rewrite an equivalent expression of 3/45 plus 5/45. When adding these two fractions together, we get 8/45. Since we used 45, which is the LCM or LCD, we significantly lower the chances that we need to simplify when we're done. 8/45 can't be simplified because 8 and 45 are relatively prime. That leaves us with prime factorizations. Remember, prime factorizations are there to help us understand what all numbers are made of. Consider the fraction 24 over 36. If I were to ask you if you could simplify this fraction, you should say yes. The technical reason being that 24 and 36 are not relatively prime. Let's break down the numerator and denominator here into their prime factorizations. 24 is the same thing as 2 times 2 times 2 times 3, and 36 is the same thing as 2 times 2 times 3 times 3. When we break these two numbers down, we notice that they have some common prime factors. Here we see they share a 2, and another 2, and a 3. When you multiply these common prime factors together, you get the GCF, which is 12. It turns out that when you divide a numerator and denominator by their GCF, you always get the most simplified fraction because the numerator and denominator are now relatively prime. It's no coincidence that 24 divided by 12 is 2, and 36 divided by 12 is 3. The most simplified form of 24/36 is simply 2/3. Now that we've briefly covered these concepts, let's dive a little deeper into them. Let's talk a little bit more about improper fractions, mixed numbers, and how to convert from each one to the other. Just a reminder, here are some examples of improper fractions: 4/3, 5/2, 9/9, and 10/4. Some examples of mixed numbers are 1 1/2, 3 2/5, and 7 1/3. Here I'm going to be talking about how to convert from one form to the other. A typical pizza has 8 slices. If you eat one out of these 8 slices, you ate 1/8 of the entire pizza. Now imagine you eat another slice, and another, and another, and another, and another, until you've eaten a large sum of slices. Imagine the total number of slices you ate was 63. We could represent this by saying that you had 63 of these 1/8 slices. 63/8 is an improper fraction represented. We can also represent it as a mixed number. Recall from earlier that a fraction bar also means division. 63/8 can also be represented by 63 divided by 8. We can use the standard algorithm for division to rewrite improper fractions as mixed numbers. While 8 fits into 6 0 times, it fits into 63 7 times. 7 times 8 is going to be 56, and we subtract with the remainder here of 7. While we could convert this into a decimal, we can also represent this as a fraction. The 7 here represents the quotient, or the whole number. The 7 down here represents the remaining parts. And this dividend of 8 here tells us the size of all of our pieces. If you ate 63 of these 1/8 slices of pizza, that's the same thing as eating 7 whole pizzas and 7/8 of another pizza. If you were to eat 64 slices, that would be 8 whole pizzas. It makes sense that we're slightly less than 8 whole pizzas because we're shy 1 slice. Now that you've seen how to convert an improper fraction to a mixed number, let's try converting a mixed number into an improper fraction. Imagine that each of these images below represents one whole Kit Kat bar. The ones that are completely shaded in are the ones that are completely eaten. There's one Kit Kat that I just could not finish and only had 1/4 of it. In total, it's safe to say that I had 11 whole Kit Kats and 1/4 of a Kit Kat. While we could count up all the individual 1/4 size pieces that were eaten, there's got to be a faster way. Each of the 11 whole Kit Kats are made up of 4 1/4 size pieces. Besides the 11 wholes, we still have 1/4 left over. Since multiplication is a shortcut for repeated addition, we can just multiply 11 times 4 to get 44 pieces with the 11 wholes. Take the 44 1/4 size pieces and add on that one extra 1/4 size piece. We realize there's a total of 45 of these 1/4 size pieces. So here we've identified that 11 1/4 is equivalent to 45 fourths. Here's a simple shortcut that some people like using to convert mixed numbers to improper fractions. First they multiply 11 by 4 to get 44, and they add the 1 on top to get 45. Writing this out plainly, we multiply the whole number by the bottom, which is the total number of pieces, and we add on the extras, which is 1. We keep the same denominator because that's the size of pieces that we're using. And we'll get 44 plus 1 over 4, which simplifies down to 45 over 4. This little process can help you convert all mixed numbers into improper fractions. Simply put, if you're converting an improper fraction into a mixed number, use long division. And when you're converting mixed numbers to improper fractions, multiply the whole number by the denominator and add the numerator. Let's put a deeper understanding of what it means to fully simplify a fraction. A fraction is fully simplified when the numerator and denominator are relatively prime. Here we have some fractions that can't be simplified. Whether you're looking at 7 and 10, or 15 and 28, the GCF between each of these numerators and denominators is 1. When we identify that their GCF is 1, we know that they're relatively prime and that they can't be simplified. Here on the right, we have some fractions that can be simplified. In looking at each of these fractions, they all have a GCF that is greater than 1. When this is the case, we know that these fractions can be simplified. Here I'm going to show you two different methods for simplifying fractions using the GCF. First, let's simplify a fraction like 14/56. The prime factorization for 14 is very short, it's just 2 times 7. 56, however, has a little bit longer of a prime factorization. I know that 7 times 8 is 56, so I'm going to put a 7 here. 8 I know breaks down into 2 times 2 times 2. So here we're going to have 2 times 2 times 2 times 7. When looking at these prime factorizations, we notice that they have some common prime factors, 2 and 7. When multiplying the common prime factors together, we get the GCF, which is 14. By dividing the numerator and the denominator both by 14, we get the most simplified version of this fraction. 14 divided by 14 is going to be 1, and 56 divided by 14 is going to be 4. Notice how the leftover prime numbers multiplied together gets us the denominator, while having no leftover prime numbers in the numerator will always get us 1. And as always, the latter method always seems to get us there the quickest. Looking at 14 and 56, most people can tell that 7 is a common factor. 7 goes into 14 2 times, while going into 56 8 times. We can add another step to the ladder. 2 is a common factor. 2 goes into 2 1 time, while going into 8 4 times. Here we can see on the left side that 7 times 2 is going to get us our greatest common factor, while the leftover 1 and the 4 on the bottom represent our most simplified fraction. If you'd like, you can add fraction bars all the way to the top to consider it as a fraction the entire way. Let's try this one more time with another fraction. Here we have 80 over 96. I know I can divide 80 by 2 to get 40. 40 can also be cut in half to make 20. 20 can be cut in half to make 10, and 10 can be cut in half to make 2 and 5. Since 96 is even, I know I can divide it by 2. That gets us 48. 48 divides by 2 to get 24. 24 divides by 2 to get 12. 12 divides by 2 to get 6. And 6 divides by 2 to get 3. By pairing up our common prime factors, we can identify what the GCF is. 2 times 2 is 4, times 2 is 8, times 2 is 16. The GCF in this problem is going to be 16. It turns out that 80 divided by 16 is equal to 5, while 96 divided by 16 is equal to 6. The simplified version for 80 over 96 is simply 5/6. Let's check this out using the ladder method. Since these numbers are a little bit larger, I can start with a 2 since they're both even numbers. 2 goes into 80 40 times, while 2 goes into 96 48 times. Since 40 and 48 still have common factors, I'm going to make another step here. Here I'm going to use a larger number like 8. 8 goes into 40 5 times, while 8 is going into 48 6 times. Again, we see our GCF here is going to be 16, while our most simplified version is 5/6. Now that we've talked about how to simplify fractions individually, let's talk about combining fractions by adding and subtracting them. Hopefully it makes sense to you that you need to have common denominators when adding and subtracting fractions. For example, if you had 1/5 plus 2/5, that's simply just going to be 3/5. When you add fractions, you keep the same denominator, but you add the numerators together. Similarly, if you had something like 3/8 plus 7/8, that would then become 10/8. Since 10 and 8 are not relatively prime, we know that we can simplify them by using their GCF. Since their GCF is 2, we can divide them both by 2 to get 5/4. At this point, you have to see what makes more sense, to keep your answer as an improper fraction or change it into a mixed number. 5/4 is equivalent to 1 and 1/4. In both of these examples, the denominators were the same. Now I'm going to talk about what to do when you have denominators that aren't the same. When adding the fractions 2/3 and 1/5, we notice that their denominators are not the same. To make these denominators the same, we're going to have to find the LCM of 3 and 5, or in this case, the LCD. Remember, the LCD is just the LCM of the denominators. When using the latter method, we can see that 3 and 5 are relatively prime. Because they're relatively prime, we know that you can just multiply 3 times 5 to get 15. In this problem, the LCD is just going to be 15. It's important to know that when the denominators are relatively prime, you can just multiply each fraction by the other number's denominator. Rewriting these fractions gives us 10/15 plus 3/15. Now that their denominators match, we can add these two fractions to get 13/15. Let's try subtracting a pair of fractions like 10/21 and 3/14. Since their denominators don't match, we're going to have to find the LCD for 21 and 14. When setting up the ladder method for 21 and 14, we do see that 7 is a common factor, leaving us with 3 and 2. Remember, we can multiply 7 by 3 by 2 to get the LCD. We can multiply 21 by 2 to get the LCD, or we can multiply 14 by 3 to get the LCD. To me, the easiest thing to do is multiply 21 by 2 to get 42. We're going to multiply this fraction on the left, on the top and bottom, both by 2, and multiply the fraction on the right, top and bottom, both by 3. Rewriting these fractions, we're going to get 20 over 42, subtract 9 over 42. 20 subtract 9 gets us 11, while the denominator stays the same as 42. Now that I've gone over all the concepts, the rest of this lesson is going to be dedicated towards examples and practice problems. Feel free to pause as you like, otherwise I'm just going to be going through all the work for each problem. In this first example, we have an improper fraction. Remember, to convert improper fractions into mixed numbers, we can use long division. So here we're going to do 43 divided by 5. When using the standard algorithm, we can see that 5 will fit into 43 8 times. 8 times 5 being 40, we get a remainder here of 3. The top number, 8, is going to be the whole number, while the remainder, 3, is going to represent the fraction out of 5. 43/5 is equivalent to 8 3/5. In the second example, we're given a mixed number, which is 6 4/5. Remember, the shortcut for converting a mixed number into an improper fraction is going to start off by multiplying the whole number by the denominator, so we're going to multiply 6 times 5, and we're going to add the numerator, which is 4. Whatever the denominator we start with, we're going to continue to keep the same denominator. 6 times 5 is going to be 30, and we're going to add 4 before we divide by 5. 30 plus 4 is going to be 34. 30 plus 4 is going to be 34 over 5. 6 4/5 is equivalent to 34/5. In example 2, we're going to practice simplifying fractions using prime factorization. The prime factorization of 12 is going to be 2 times 2 times 3. The prime factorization for 20 is going to be 2 times 2 times 5. After pairing up their common prime factors, we can see that we're left with a 3 and a 5 here. The simplified version of 12/20 is 3/5. Use the GCF of 4 to help us get us that. In the second example, we have to find the prime factorization for 42 and 56. 42 breaks down into 6 times 7, and 6 breaks into 2 times 3. So we know it's going to be 2 times 3 times 7. 56 breaks into 7 times 8, and 8 breaks into 4 times 2, and 4 breaks into 2 times 2. So here we know there's going to be 3 2s and 1 7. When pairing up their prime factors, we notice they both have a 2 and they both have a 7. We can see the top has only a 3 left over, while the denominator has 2 times 2, which is 4. 3/4 is the most simplified version of 42/56. GCF of 14 helped us simplify to get 3/4. In example 3, we're going to practice adding fractions using the LCD. In this first example, we're going to notice that 4/5 and 3/4 have uncommon denominators. Since 5 and 4 are relatively prime, we can just multiply by the other fraction's denominator to get the LCD. Rewriting these fractions, we're going to get 16 over 20 plus 15 over 20. When adding fractions, we just add their numerator, so 15 plus 16 is going to be 31, while we keep the same denominator of 20. The answer in improper fraction form is going to be 21 over 30, while the mixed number version is going to be 1 and 11/20. In this next example, we have mixed numbers. Here we have 2 and 1/6, and we're going to add 3 and 3/4. When adding mixed numbers, you can always just add the two whole numbers together. 2 plus 3 is going to get us 5. The only part that's really going to take us some work is finding the LCD for the 6 and the 4. When using the latter method, we can see that 2 is a common factor, leaving us with 3 and 2. When multiplying the diagonal here, we can see the LCM or the LCD is going to be 12. We can multiply this fraction by 2 on top and bottom, and multiply the second fraction by 3 on top and bottom. Since we already took care of the whole numbers, we just have to take care of the fraction part now. The 1/6 is going to become 2/12, while the 3/4 is going to become 9/12. Adding these two fractions together, we're going to get 11 on top, and we're going to keep the same denominator of 12 on bottom. The final sum is going to be 5 and 11/12. In example 4, we're going to practice subtracting fractions using the LCD. In this first one, we're going to look at the fractions 8/11 and 3/5. Since their denominators 11 and 5 are relatively prime, we can just multiply them by the opposite denominator to get the LCD. For the first fraction, we're going to multiply by 5 on top and bottom, while for the second fraction, we're going to multiply by 11 on top and bottom. When rewriting our fractions, we're going to get 40 over 55 minus 33 over 55. Now that the denominators match, we can actually subtract these fractions. 40 minus 33 is going to be 7, while the denominator stays the same. The answer for this first one is going to be 7/55. In the second one, we're going to take 3 and 3/4, and we're going to subtract 1 and 5/6 from it. When subtracting mixed numbers, it's important to actually look at the fractional parts before you look at the whole numbers. If the second fractional part is larger than the first fractional part, we're going to run into some problems if we start with the whole numbers. Since 5/6 is larger than 3/4, if we were to subtract them, we would have a negative value. To fix this issue, we're going to borrow one whole from the 3 and make it a 2. When we borrow one whole from the 3, we can rewrite it as 4 over 4. We'll still have the 3/4, and the remainder of the problem will stay the same. By regrouping one of the wholes in the first fraction, this allows us to subtract the fractional parts without going into the negatives. I know it may seem a little strange to have an improper fraction in a mixed number, but it's temporarily okay. When subtracting these two fractions, let's find the LCD. Since 2 is a common factor, we're left with 2 and 3. We can see that the LCD is going to be 12 here. We're going to multiply the first fraction by 3 on top and bottom, and multiply the second fraction by 2 on top and bottom. When rewriting these fractional parts, we're going to get 21 over 12 minus 10 over 12. When subtracting, we're going to get 11 over 12. Well, the fractional part is going to be 11/12. We still have to subtract the whole numbers to get 1. Here, our answer is going to be 1 and 11/12. Here in example 5, we have some application word problems. Pause the video to try them on your own and unpause when you're ready to see the solutions. And that just about wraps up our lesson here on fraction basics for pre-algebra. I hope you were able to link your understanding of prime factorizations, GCF, LCD, and relatively prime to fractions. These concepts will be important stepping stones for future lessons to come. Thanks for stopping by. I'll see you guys in the next one.